Good morning, everybody. It's Coach Razzo here. So in this video, um, what needs to go ahead and happen is that we're going to go ahead and cover composite figures, but in this case, we're going to be working with the shaded regions. So for number 4 here, what it talks about is that it's like, oh, we have to go and look for the area of the shaded region. As you can tell, it kind of looks like it's like missing a part inside of it. So round to the nearest hundreds if necessary. So always be careful with your what you're rounding with, especially when you run into the nearest hundredth. And so there's two figures here. So first figure and then second figure. So your first figure, it's initially this. So you have 19 and 15. So you kind of have like a rectangle going on, and then in part 2, where you got in figure 2, you have more of a rectangle going vertical, and so you have 9, and then you have 4. Now, the question for which comes first and which comes second, because it's different for everybody. I'm not going to go ahead and say that, oh, this is always going to be first figure. Whatever best works for you. So if I'm looking for the area of the shaded part, this whole entire shaded region, then I need to go ahead and look for my area, which is base times height. So it'll be 19 times 15. And so in this case, when you go ahead and multiply those two, let's see, I'm going to go ahead and get the value of, let's see, 19 times 15, using my calculator here. So I got 285. Okay, so there you go. So first figure is 285 inches squared. And so from here, inches squared. Now the next part we have going on here, if we go ahead and say that we have 9 and 4 for our unshaded region, then we can go ahead and multiply those two according to base times height. So it'll be 4 times 9, which is 36. So this would be 36 inches squared. Okay, so these are your first two that you have going on. But now the thing is that makes these different from the other ones is that the ones over here, you kind of had to add them up and combine them and so forth. So the ones down here, what needs to go and happen is that you want to go ahead and cut them so they won't be a part of each other. So I'm going to take this right here, and I'm going to go ahead and cut it out from this shaded region. So I'm going to go ahead and take 285 minus 36. Let's see. Minus 36. I'm trying to do it on my calculator over here. And I got 249 inches squared. So there you go. So that's what we have going for number 4. Now, if you look at the next one, what needs to go and happen? If you look at the next one, you kind of see a circle, and then it's going inside of a square. And we want to go ahead and get this to where it's going to go ahead and cut each other apart. So as in like you have a slice of cheese, and then you got like a little circle cutter, a cookie cutter. You want to cut that part out. So additionally, that's what's going on here. And then what's left over is whatever like little cheese left over or dough, whatever situation that you can think of from here. And so my first case, my second case. So my first case, initially, it's like a circle. My second case, it's initially this. So I got 50, and it goes like all the way around. So if I know my circle goes from here to there, and that's 50, that means my diameter is going to be 50, which means the radius is going to be half of the whole entire distance from edge to edge, which would be 25. So if I'm looking for the area of a circle, which is pi r squared, pi 25 squared. So you want to square 25 in this case. Square it, and you get 625. 625 pi. And that's going to be centimeters squared. Now, this being said, what we have going is that area is equal to whatever you have going on. So from here, if I have 50 on the top, I got 50 on the right. And because it's going to be a square, because circle is all the same distance around it, so the distance from here is the same distance from here. So as you're going, for a square, you can use base times height. You can use s squared for side squared, but just go and keep it simple and use b squared. So 50 times 50, which is 2,500. And so now you have what you have. So the whole entire blue right here represents 2,500, okay, centimeters squared. So I need to add in there. So centimeters squared. Now this part right here is what we're going to go ahead and cut out. So if I go over here and I'm trying to cut this out, I'm trying to cut out this little green part I just made up, and then whatever blue part's left over is what I want. So this would be 625 pi, and then if I'm need to round it to the nearest hundredth, I'm going to use my pi symbol in my calculator, and so I have 1963.4, and then round to the nearest hundredth, which would be 0.46. Okay. So then I have centimeters squared. Now in this one, my original other region is going to be 25. Let me use a different color. 2,500. So 2,500 centimeters squared. And then from there, these two parts, are we going to combine them, or are we going to go ahead and subtract them from each other? So obviously we don't want that. We don't want to go ahead and combine them because you don't want to stack them on top. You want to go ahead and cut out that piece from the square that you got, cut it out, and you want to go ahead and be left over with anything that is, anything here, because you want to go ahead and receive. So this is what you want to go ahead and have by the end of all this. So this is going to go ahead and be my shaded region. So I'm going to go ahead and take out the 2,500, and I'm going to subtract 625. Oh no, my fault. I'm going to subtract 1963.46 from it, and that's going to give me my shaded region. So I'm going to go ahead and subtract that from 2,500 minus 1963.46, and that would give me 536.54. So 536.54 centimeters squared. So that's gonna be my final value for my shaded region. Okay. All right, guys. So this is what I have so far for composite figures. So on the shaded regions. So using examples to go ahead and piggyback off, and hopefully you can do well. Okay. All right. Tune into the next.